it's time to look at our favorite portion of the trig here, was dealing with rationals and rational equations and the graphs of rationals. So since it was so much fun, I figured we ought to look at it again. So I'm going to have two graphs here. Here are my two rational functions I'm going to look at. And we have lots of things that we're going to find. Discontinuity, classifying each discontinuity, asymptotes, zeros, and finding f of 0 or g of 0. So again, anytime I'm giving a rational function, anytime that I'm given that, what I'm going to first try to do is to factor, top, factor the bottom. So when I factor the top here, I would get x plus 3 and x minus 2. And on the bottom, I could factor out an x, and it would leave me with x squared minus 2x minus 15, which could be simplified to x plus 3 and x minus 5. Let me do the same thing here for g of x. Up top, I can factor out a 3. I'd be left with x squared minus 4. Well, x squared minus 4 is a perfect square, so I can simplify that as well. X squared minus 4 would become x minus 2 and x plus 2. On the bottom here, I get x plus 5 and x plus 1 as my factor for the bottom. So, again, always a good idea to try to just get your discontinuity, or I'm sorry, get your factoring out of the way, because you can read almost everything based on the factoring. So first, where is a function discontinuous? Rationals are discontinuous when the bottom equals 0. So, for the first guy, bottom equals 0 at 0, -3, and positive 5. Main thing here, don't forget that 0. That's going to be the main guy that end up being forgotten. Okay? For this guy, x equals -1 and -5 are your two discontinuous points. That's when the bottom equals 0. Okay? Classify each discontinuity. What that means is each discontinuity a vertical asymptote, or is it a hole? Well, remember, vertical asymptotes happen when the bottom equals 0 and it does not cancel. Holes happen when they do cancel. So, did 0, which came from this x, did it cancel with something up top? No, it didn't. So that means it was an asymptote. -3 came from this factor. Did it cancel? Yes, it would have canceled with that guy right there. So, this guy would have been a hole. And then x equals 5 came from this part. Did it cancel? No. That's why it's a vertical asymptote. For g of x, both of these guys, neither of them canceled anything up top. So they are both vertical asymptotes. -1 and -5 are both vertical asymptotes. Now, horizontal asymptote. The main thing that you should be looking at here are the degrees. Degree of the top, degree of the bottom. Top and bottom. If the degree of the top, excuse me, in this case, we have the degree of the top being smaller than the bottom. What's bigger? The bottom's bigger. That means that the bottom is growing more quickly. That means that I'm dividing by a big, huge number. That means my horizontal asymptote is going to be y equals 0. Because no matter what, I'm going to have a number dividing by a bigger number. Eventually, I'm going to go towards 0. We'll talk more about that down the road. Mainly remember, bottom's bigger, I'm going to approach 0. In this one, the degrees are the same. When they're the same, that's when we just look at the coefficients. So I look at that number, 3 and 1. 3 divided by 1 is just 3. So that is your horizontal asymptote. Alright, zeros of the function. That means when does the function equal 0? If a fraction equals 0, that means the top equals 0. So I set each of the guys up top equal to 0. So I'm going to get x equals 2. And you might say -3, but could I have -3 to begin with? No, because I'd be dividing by 0. So just 2 is your answer for the zeros of the function, just like we've done before. Alright, and then for this last guy, for this part here, zeros, when is this guy, the top equals 0? Well, 3 can never equal 0, so we don't worry about that. This guy equals 0 when x equals 2. This part equals 0 when x equals -2. So those are your two zeros for that one. Now, for f of 0 and g of 0, that just means literally plug in 0. So if I plug in 0 here, I would get -2 up top, and on the bottom I would get 0 and -5. Well, if I'm dividing by 0, well, I can't do that. So if I'm dividing by 0, I should get something that is, well, we would say undefined. What I'm going to look at here is that I'm actually going to get an answer, of either infinity or negative infinity. That's what we would need to eventually figure out what that is going to be, and we'll talk about that down the road. Excuse me. For the second one, if I plug in 0 again, up top I would get 3 times 2 times negative 2 up top. On the bottom I would get, if I plug in 0, 5 and 1. So I would get 3 times 2 times negative 2, which is negative 12 divided by 5. So this is negative 12 over 5. And that's all we need to look at for that. Now, just a couple things I want to mention is this is a number that doesn't exist, first off. F of 0 cannot possibly exist. Why not? Because we said it was discontinuous. However, we can kind of use this idea of plugging in to find something called a limit. The limit as you get close to 0, because we don't know what we have at 0, because we said right there it is discontinuous. What we can do is kind of plug in and find out, well, we know it's undefined because you can't divide by 0. However, well, it looks like it's going to approach, it's either going to be infinity or it's going to be negative infinity. We'll talk about how we know that as we move down further. In this case, it is going to be a positive infinity. Okay, we could have done the same thing with negative 3, because negative 3 is a whole. This actually would become a lot more interesting. I could kind of look and see, well, if I plugged in negative 3, I know I would get, 0 over 0, but what is that? Well, if I cross those guys out, I can plug in negative 3 again. I get negative 5 up top, negative 3 and negative 8 on the bottom, and what would I get? 5 over 24, negative 5 over 24. That's actually what the limit as you approach negative 3 is. So again, we'll talk more about limits down the road, but all it becomes is literally plugging into a function. So it's really not anything new, it's really not anything too difficult. It's just a matter of us looking through the steps. But the main part you need to remember are vertical asymptotes versus wholes, and remembering horizontal asymptotes and how to find the zeros of the function. Those are the main points that we need to remember from rationals. Especially that part you hated the most, knowing what a horizontal asymptote may have been.